Hello, my friend. Welcome to my channel. So today I'm going to talk about a discrete probability distribution, which is a very famous one, binomial probability distribution. So in a binomial experiment, these are the requirements, right? The first one is number of trials. Number of trials is fixed. And the second condition to be a binomial experiment, each trial has two outcomes. So for example, it can be success or failure. The third condition is outcomes of each trial are independent. So the outcome of one trial does not affect the outcomes of the second trial. So that's two trials are independent, right? Outcomes are independent. So then the probability of success remains the same for each trial. So these are the four requirements to be a binomial experiment, right? And here we are going to use some notations. So the probability of success, we use simple p for the numerical value. This is numerical value of probability of success. And we are going to use q, which is 1 minus p, as numerical value of probability of failure. And n equals number of trials in the binomial experiments. So let's look at this example, tossing a coin, right? A coin is tossed 3 times and we are going to find the probability of getting exactly 2 heads. So by looking at this example, you can identify this is a probability, a binomial probability distribution. If you want, you can write down all the outcomes, right? The sample space will be like, since this is a 3 times toss, so we are going to toss 3 times. As you can see, a coin is 3 times, then you have fixed number of trials, right? So in this case, your n equals 3. And the other thing is only 2 outcomes. What are those 2 outcomes? Head and tail, right? And as you can see, outcomes are independent, right? And outcomes are independent. And the probability of success. So in this case, the success defined as heads, getting heads, right? Probability getting head is your success, okay? So here probability, since we have 2 outcomes and this is a fair coin, then getting head is out of 1/2, right? 1/2 is the probability. So this half is the same for all trials, right? So this is a binomial experiment. So when you have a binomial experiment, the probabilities can be calculated like this. When you need to find the probability exactly X number of trials. So here X X represents X is number of successes in trials, right? So we can calculate this one like this. NCX, probability of success to the power X, 1 minus, which is failure to the power N minus X. So NCX is N choose X. We can write down N factorial over N minus X factorial times X factorial, right? Using this formula, we can calculate all the probabilities of X's, right? So let's look at this example. We are here N equals 3, P equals 0.5, and Q, or 1 minus P, equals 1 minus 0.5, which is 0.5. And here exactly 2 heads. So success is getting heads. So I'm going to find probability X equals exactly 2. My X value is 2 now. And here we are looking at 2 successes, or the 2 heads in 3 trials. So we are going to use the formula. My N is 3, choose 2, X is 2, and probability of success is 0.5 to the power X, X equals 2, and then 1 minus 0.5 to the power 3 minus 2. So this is 3 choose 2, 0.5 to the power 2, here also 0.5 to the power 1, right? As you can see, if you expand this one, 3 factorial over 3 minus 2 factorial times 2 factorial, here 0.5 square times 0.5. Here we can simplify. Here 1 times 2, here 1 times 2 times 3. So here we have 3 left, and here 3 minus 2 is 1. 1 factorial 1 is 1. So 3 times 0.5 square times 0.5, which is 0.375. So this is the probability of getting exactly 2 heads in this experiment. So I hope you understand this binomial probability distribution. So if you have any questions about this, please comment. And if you want to see more videos like this, please subscribe to my channel. And thank you so much for watching this video. Bye.